Okay, so today in geometry class we're covering section 2.6, proving statements about angles and congruence. So we're in geometry here. Okay, the first thing we started off with was theorem 2.2, learning the properties of angle congruence. We said they are reflexive for given any angle A, right? Angle A is congruent, of course, to angle A. Symmetric. If angle A is congruent to angle B, well, that would imply that angle B is congruent to angle A. And transitive, if angle A is congruent to angle B, and angle B is congruent to angle C, that would imply that angle A is congruent to angle C. So that's angle B right there. So again, nothing new. We've seen all those before. Then we went into a proof here. And what we started to do is just taking a look at the left-hand side for the statements and following the logic and see if we can get it here. So here's what we did, right? So given that the measure of angle 3 was 40 degrees, so we went ahead and we highlighted. We knew that the measure of angle 3 was 40 degrees, so we highlighted that one. The measure of angle 1 is congruent to measure 2, so we did that as well, angle 1 and angle 2. And then angle 2 and angle 3 are the same, so we highlighted those as well, coloring them in, so this angle and this angle are the same. Could you then prove that the measure of angle 1 was also equal to 40 degrees? So here's the logic that we did. Okay, so first we said the measure of angle 1 is congruent to the measure of angle 2, that's given. The measure of angle 2 is congruent to the measure of angle 3, that's also given. Now, since 1 is congruent to 2 and 2 is congruent to 3, we can say 1 is congruent to 3 by the transitive property of congruence, or transitive property of equality, excuse me. Now, if the measure of angle 1 is congruent to the measure of angle 3, and angle 1 is equal to angle 3, that's the definition of congruent angles. And then since we know that angle 3 is equal to 40 degrees, we can substitute it right back in for there to get the angle 1 is equal to 40 degrees and got substitution. So there was the proof, the first proof that we did. Then everybody did a U-try. And the U-try was, given that angle A is congruent to angle B, can you prove that angle B is congruent to angle A? So first we said, yeah, okay, angle A is congruent to angle B, given. So that means angle A is equal to angle B. That's the definition of congruent angles. Therefore, angle B is equal to angle A. That's symmetric property of equality. And then we can get to the spot where we need to be. Angle B is congruent to angle A, definition of congruent angles. Then I did a little demonstration of the conjugate supplement theorem, the conjugate complement theorem, and then the linear pair postulate. I brought up the GeoGebra, and we took a look at that. So we went over theorems 2.4, 2.5, linear pair postulate. The most important one was probably this one right here. It says that if two angles are adjacent to each other and they form a linear pair, then their sum has to be 180 degrees. Okay, then we went on and did a pretty big proof together here. So let me view it down so we can see it a little bit here. Let's go to 75%. There we go. So here was our reasoning here, right? So given that angle 1 and 2 are supplementary, and angle 3 and 4 are supplementary, and 1 is congruent to 4, can you prove that 2 is congruent to 3? So again, we start off and said, okay, well, 3 is congruent to 4. 3 and 4 are supplementary. 1 and 2 are supplementary. So that means that the measure of angle 1 plus the measure of angle 2 is 180, and same thing with that. The measure of angle 3 is equal to the measure of angle 4, right? The first two were given. The second two are the definition of supplement angles, right? If two angles add up to 180, or if two angles are supplementary, then they have to add up to 180. So then this was the tricky part of the proof, right? Since both of these are equal to 180, that means that they have to be equal to each other. That was the same line that we wrote down here for substitution. Okay, so measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 3 plus the measure of angle 4. Then we use the fact that we know the measure of angle 1 is congruent to the measure of angle 4. Ooh, I should have put that in there. That goes right here, excuse me. Measure of angle 1 congruent to the measure of angle 4. So that means that, and that was given. So that means that 1 and 4 are the same. So that means that the measure of angle 2 is equal to the measure of angle 3 when you subtract the measure of angle 1 from both sides and the measure of angle 4, giving you that the angle 2 is congruent to angle 3 by definition of congruent angles. That was kind of tough. And again, I left this part out in the proof, so make sure you take a look at that. Okay, that was basically what we did. Then we had some homework, 1 through 18. Oh, okay, good luck.